Hey guys, hopefully everybody's had a good week so far. I'm going to give you your next assignment. Just didn't want to run up too close to the due date. I wanted to give you plenty of time to kind of work on your last few assignments. So that's where you're getting to this week. Anyways, this is 9-4, which is an arithmetic series. We've already done arithmetic sequence. Now we're going to get into series. So just the difference in those is that a sequence just kind of goes on and on. A series has a finite number of terms, and so we're going to learn how to find the summation of those terms. So an example of what I mean would be like example 1. So find the sum of the first 100 positive integers. So like what we're doing is we're trying to find the sum of like what's 1 plus 2 plus 3 plus 4 plus, and you see that that would be a lot of typing in your calculator. And so anyways, we're going to learn how to basically do that in a mathematically kind of, what's the word I'm looking for, just a better way. So anyways, getting into that, finding finite sums. So 2a, what is the sum of the arithmetic series where a sub 1 equals 7, a sub n equals 79, n equals 8? So here is our formula right here. So a sub n would be the last term of the series, and n is what is n? Let's see, what does n stand for? So sorry, n is the subscript of a sub n. So that makes that tells us that 79 is the 8th term. Sorry about that. Anyways, we're just going to use the formula, kind of plug and chug. So S sub n equals n over 2, so 8 over 2 times the quantity a sub 1, which is given to be 7, plus a sub n, which is 79. So in my calculator, I'm just going to type 4 times 86, and we get 344. And that's my birthday, just so you know, April of 86. A good start to the notes. So B, what is the sum of this arithmetic series? So we have a sub n is 80, n is 11, d is 7. What we don't have is a sub 1. So we do need that because we have to have that. So we kind of go back to 9-2 here, and we're just gonna figure that out. So anyways, so we have a sub n here would be 80 equals a sub 1, which we don't know, plus n minus 1, so that'd be 11 minus 1 times d is 7. So that just gives us 80 equals a sub 1 plus 10 times 7, which is just 70. So subtract 70 from both sides, and we get 10 equals a sub 1. So sometimes you got to do a little bit of algebra to figure out that missing variable. Then again, we're just ready to plug and chug. So n over 2, so that would be 11 over 2 times a sub 1, which is 10, plus a sub n, which is 80. So 11 over 2 times 90 is 495. So again, I think I could just kind of jumped into it, but basically what we're saying here is that, so think about this as a series, right? A sub 1 is 10. The common difference is 7, so we're skip counting by 7 and going up to 80, right? So we're doing 10 plus 17 plus 24 plus dot, dot, dot. And eventually we get to 80, and that's equal to 495. This is the shortcut to that, okay? So that's what we're doing. Just wanted you to kind of understand what we're doing there, okay? So what's the sum of this arithmetic series? So we know a sub 1 is 14. Can we tell what the common difference is? Do we need the common difference? No, we don't need the common difference for this. We need to know, well, I guess we do. We do need to figure out which term the 116 is. So we don't know n here. We know a sub n is 116, but we don't know, we're missing n, like what number term is that? So in order to know that, we do need to identify that the common difference is 3. So, yeah, we're going to go back to this formula right here. So we're going to say 116, which is a sub n, equals a sub 1, which is 14, plus n minus 1, so we don't know n minus 1, times the common difference, which is 3. So that's where that's going to come into play. All right, and then we're just going to solve for n algebraically. So that would mean distribute the 3. So 3n minus 3, combine like terms, and then we're off. I'm going to skip a step since I'm kind of, well, I guess no, I'm not, since I already wrote it. So plus 11, so subtract 11 from both sides, going to give me 105 equals 3n. Divide both sides, we get 35 equals n. So again, had to do a little bit of work, but now we have everything we need to find that summation. So n, which is 35 over 2, times the quantity 14 plus 116. So 35 over 2 plus, what would that be, 130 is going to be 2275. All right, so kind of similar on the next one. I guess I'll do that since we have some negatives, but really it's the same kind of deal here. So we know a sub 1 is 20. We know a sub n is negative 24. What we don't know that we need is what's n. What number term is that? Okay, so negative 24 equals 20 plus, what's my common difference? It's negative 2. So we could write minus 2 times the quantity n minus 1. And then we're going from there. So that's going to be 22. If I take away 22 from 24, that would give me negative 46. So that tells me that that is the 23rd term. And then so I'm going to use that. So 23 over 2 times the quantity 20 plus negative 24 minus 24. That would be an easier way to write that. So that would just be going to give me negative 46. All right, so the last thing we kind of cover here is summation notation. You may or may not have seen this before. Those of you who go on to take pre-calc and obviously calc, you're going to see this a bunch. So this will be your, I guess, first introduction to this. So summation notation. So this is the capital Greek letter sigma. I'm going to skip over that definition because it's kind of all says what everything means. So this top number above sigma is the last value of n. So we usually refer to that as the upper limit for UL. That's the last term, okay, the last term. And then this guy down here is your first term, or the lower limit. Or LL. And then that's obviously just your formula. Okay, so let's see how we can do this. So what is the sum of the given series? So again, just to copy our formula, S sub n equals n over 2 times the quantity a sub 1 plus a sub n. So what do we know? Well, we know a sub 1 is 1. We know that sorry, no we don't. So we know, sorry, we have to find a sub 1. So a sub 1, that means we have to sub in 1 to find a sub 1. So sorry about that. So that'd be 3 times 1 minus 8, be negative 5. So a sub 1 is negative 5. And then a sub 40 is 112. And then we need to know, well, we already know n is 40, okay? So that's n. So now we have everything we need. So we go 40 over 2 times the quantity negative 5 plus 112. These aren't too bad. Just knowing what you're being asked is the key. So S sub 40 is 2140 is what we get. All right, and the next one, we are trying to figure out what's the summation. Well, I'm going to skip that one and just do C. So what's the summation of the 4th term to the 12th term is what we're looking for here. So we're not actually starting at the 4th term. So a sub 4 equals negative 2 times 4 is negative 8. A sub 12, negative 2 times 12 is negative 24. And what term would that be of the sequence? So you got to be a little bit careful here. So let's think about this first thing right here. So how would we get 40 from n using these two numbers? So if we do, you got to be careful, because if we do 40 minus 1, which is what you might think, we get 39. So you're always 1 off that way. So you always have to add 1. All right, just like on this next one. Well, we might do that one too, because we'll see. So anyways, n here is 12 minus 4 plus 1 So it's not eight terms, it's 9 terms. So remember that when you're counting, you always want to kind of intuitively be off by 1. So we're going 9 over 2 times the quantity, -8. I'm just going to write minus 24. And so we get S sub 9 equals -144. Okay, and then this last example just wants us to basically write this arithmetic series in summation notation. All right, so that is a sub 1, 5 is, and 25 is a sub n. So I'll go ahead and make my Greek letter here. All right, so what is my lower limit? Well, that's the first term of the sequence, so we're starting at the first term, and we're going up to which term? So how many, what's in here? So that's 1, a sub 1, 2, 3, 4, 5. So we went to the 5th term, and now we have to come up with the rule. So what is the rule for this? You could think of it as a sequence or a series here. So I think it might be obvious on this one, but here's how you could kind of set that up algebraically. So a sub 1 is 5. My common difference is 5. So go ahead and just distribute 5 and minus 5. And then combine like terms. 5 minus 5 is 0. So overall, it's just 5n. Like I said, that was may have been obvious. All right, and then on the last one, we're going to do the same thing. So first part's pretty easy and obvious. Starting at term 1, going up to term, that's 1, 2, 3, 4, 5, 6, 7. Now, can we figure out what our function rule is, our series rule is? So a sub 1 is -2 plus the quantity n minus 1 times the common difference. So that would be 2 in this case. So -2 plus 2n minus 2. So 2n minus 4. All right, so there you go. This not necessarily the hardest lesson in the world, just understanding what you're, kind of figuring out and what it all means and what you're being asked to do. So just to wrap it up, now that we know how to do this, can we easily answer this question? Let's see. So, well, let's see. So S sub n, so we want S sub 100 here. So we're going to do 100 over 2, because there's 100 terms if we count the first 100 positive integers. A sub 1 is 1. A sub n is 100. So basically we have 50 times 101. So that'd be 5050. So a lot easier than adding all those up. Anyways, if you guys have any questions, let me know. Tuesday will be a work day, and then we'll probably do some kind of learning check after that. So you guys have a great weekend, and I'll see you next time.